Okay, for number 17, we are given 2 points, and we need to find the linear function. So they tell us it's going to be this equation y equals mx plus b, where m is the slope and b is our y-intercept. So those are the two things we're going to find. It'll have y and x in it. So we could label this first point x1, y1, and the second point x2, y2. And then we start with the formula, slope formula. Slope is equal to y2 minus y1, or the other way around. You'll see the important part is whichever point you choose to be in the first spot for the y value, whichever coordinate you use the same x coordinate down here. So then it's x2 minus x1. So we're down here, y2 is negative 2. Let's go up here. Negative 2 minus y1, which is negative 6. And then in the denominator, since we started with the negative 2, we go with the positive 8. Subtract from here x1 negative 8. So we end up with negative 2 plus 6 and in the denominator 8 plus 8. So that leads us to a fraction. We have 4 in the top, positive 4, 6 minus 2, over 16, 8 plus 8, which reduces down. 4 goes into both the numerator and the denominator, leaves us with 1/4. Now we could write that as 0.25, but they say no decimals, so we'll leave it at that. So now we know what the slope is. We know that m is 1/4. Now what we do is we take one of the points, whichever one we want. I'm going to take this one that has fewer negatives. I have might be a little less problem for me, 8 minus 2. And so remember, this first coordinate is an x value. The second coordinate is the y value that gets paired with that x value. So we get to plug that in here for x. So we get 1/4, 8. And think of this as 8 over 1, because to make it like a fraction, right? We're multiplying. And when x is 8, y is negative 2. And that's going to allow us to find the y-intercept. Can multiply straight across, so that gives us 8 over 4 equals negative 2. This reduces down to 8 divided by 4 is 2 plus a b. So we get negative 2 equals 2 plus b. Subtract 2 from both sides to solve for b. And we've found that b is equal to negative 4. So this gives us the equation, sort of like what we had right here, except now we know what b is, so we just rewrite it y equals 1/4 x minus 4. That's our linear equation. Put that in. And they want the equation, so we do have to put the equal sign. Y equals 1 divided by 4 x minus 4. And again, you could also use it, but it checks the syntax for us. We're all okay. Let's see if it worked out. It worked out good. 17. Move on to 18. Okay, this one is we're going to be dealing with vertical lines, horizontal lines, and in the two special cases of the vertical and horizontal lines. So vertical lines are a special case. Remember, a vertical line is something So if it's going through the point 5, 6, here's 5, 6, we'll call this 5, 6. The vertical line that goes through 5, 6 has to go through, it is basically a vertical line. It's telling us what x is. So this right here is giving us the equation. It's just x equals 5. So for vertical lines, it's the x coordinate of any point that it goes through, because all the x coordinates, this line goes through, any point on this line will have an x coordinate of 5. That's what that tells us. That's what we know. So it's always going to be x equals 5. Vertical lines, x equals 5. Horizontal line passing through the same one. So if we take a horizontal line that goes through there, what we know is that it's going through at y equals 6, and every point on this line is going to have a y coordinate of 6. The x will change. So that's the equation, y equals 6. I don't know what happened there. I don't even remember putting that 5 there. Y equals 6. So what's the x-axis going to be? Well, the x-axis is right here, right? So that's a horizontal line. It's got to be y equals something. It's got to be y equals 0, because it hasn't gone up or down. And the y-axis itself is a vertical line, so it's got to be x equals, and it's x equals what? Well, it's going through 0. It's got to be x equals 0. Okay, so we'll put those two in there. X-axis is a horizontal line, and this is kind of, people say, isn't that kind of backwards? It is kind of backwards. The x-axis is defined by an equation of y. The y-axis is defined by an equation of x. It's just the way it is. And it works. So become familiar with these. Let's take a look at 19. Keep moving along. Now we need to draw an accurate graph of this function. The tools we have are, as you can see here, is the line drawing tool. We need to get 2 points and connect them. So the one I would start with is the y-intercept. And then we'll use the slope. So the y-intercept is 3, and it's 0, 3. So we start here, 1, 2, 3. There's our first point. Now to get to the next point, I use our slope. And what we have is we have a negative 3/4. So that means we can apply it in a couple different ways. So negative 3/4. When we use our slope, remember the top is the rise, the bottom is the run, or the horizontal direction. This top gives us the vertical direction. So we can look at this as negative 3. So we're going to go down 3 and then over 4. Or you could do it as up 3, the negative on the bottom, and back 4. Either way, you'll get those points. So, and I'll show you, you get both of them at the same time, sort of. So we could go up 3. Which one are we going to do? Set up 3. 1, 2, 3. I haven't clicked on anything. And then go over 4. 1, 2, 3, 4. There it is. And notice I would have got the same line had I gone, go here, down 3, 1, 2, 3, and then back 4, 1. Wait a minute, what did I do? I went up 3, oops, I messed up here. I went up 3, so I got to go back 4. I went the wrong direction, because notice this is going uphill. This negative tells me it should be a downhill. Okay, so be careful. Let's clear it. Let's try that again. So we start with our y-intercept, 0, 3, 1, 2, 3. And again, if we go up 3, we've got to go back 4. So 1, 2, 3, and then we've got to go back 4. 1, 2, 3, 4. Click it there. Now I'm going to show you why it's good to do both of them is how I caught my error. Now when I do this one, if I go down 3, 1, 2, 3, I should go forward, go to the right for 1, 2, 3, 4, and then I need to end up back on that line, which I do. So now, and it's going downhill, so it is negative. That's what we need to do with this one. Okay. So use the y-intercept to get your first point. Use your slope to get a second point. And we got it right. Clear that out. 19, and we'll take another little break. So systems of equations. They want us to solve these two systems of equations by graphing. So we're going to draw these two graphs. They suggest right solution order pair does not exist. We kind of have the same thing. Now, these are not in y equals mx plus b. You could, but I'll show you what we can do is we just need 2 points. So one way to do it when it's in this form, one of the best ways, is to do what they call the intercept method. Is you're going to plot both intercepts. So you'll let x equal 0, and you'll figure out what y is, and then you'll let y equal 0, and you'll figure out x. Okay. So what you can do is, when you put in 0, that part goes away, and you're just left with one part. So let's start with x equals 0. So that's 5 times 0 plus 2y equals negative 10. Notice what happens is 5 times 0 is just 0. This just disappears, and we've got 2y equals negative 10. So we can solve that simply by dividing both sides by 2. And we've got that y equals negative 5. So when x is 0, y is negative 5. So that's 1 point we get over here. So how do we do that? 0, negative 5. And we'll plot this one just by plotting the 2 points. So that's 1 point. We need the other point, which is going to be the x-intercept, right? We're going to plug in 0 for y. Same equation. We're going to have 5x equals 2 times 0 equals negative 10. And we see that this becomes 0, so we end up with 5x equals negative 10. Divide both sides by 5. And that gives us that x equals negative 2. And that's when y is 0. So the other point we get is negative 2, comma 0. So we'll plot that point, those 2 points, and we'll have the first line. So 0, negative 5. And then negative 2, 0. So there's the first line. Okay. We do the same thing for the second line. Okay, so we're going to take this one now, plug in 0 for x. That just goes away. We end up, this is a shortcut way. I just say, so I got 4y equals 8. Divide both sides by 4. And I get y equals 2. Okay, and so that gives me the point. What did I do? I let x equals 0, y is 2. So that's that one. I'll do the same thing, put 0 in for y, so 4 times 0 is 0. So then I just get 3x equals 8. And I don't get as nice of a point, but that sometimes happens. Divide by 3, divide by 3, so that I get x equals 8/3. And that's when y was equal to 0, so it's going to be 8/3, 0. Okay, now let's see if I can do this up. When I go to plot another line, so 0, 2 is not a problem. I go to 0, 2, there we go. 8/3. And sometimes they let me put in No, it's not going to be. It's 8/3. 3 goes into 8 twice. That's like 2. It doesn't let me do that, does it? I know it's somewhere between 2 and 3. So like halfway in there. I need to find another, yeah. Sometimes there's a tool where they let you actually enter in the coordinates, and that's what I was hoping we had, but we don't. So we have to do something else. I don't want to clear all of this. So I know 0, 2 is one of my points. Okay, so that's going to work. Now what I need to do is figure out what would come down a little bit more, right? I need to figure out what would be something that would give me an integer value, because that's all I can really graph. So let's see if I can that's not a nice point. This is a good point. 0, 2. So when x is 0, y is 2. Let's let, instead of let y equals 0, let's plug in a new value for x, because what I can see is that y will, since y is even, so we plugged in 0 for x. Another thing we could do is let's just plug in, any number we want for x, and then we'll solve for a new y value. That gives us a second point. And what I can tell is we're going to divide by 4, so as long as this plus 8 is divisible by 4, then it'll work. So the best way to make it divisible by 4 is put in x equals 4. So I'm going to put in x equals 4. That'll give me 3 times 4. And this will always work, so I want to get a multiple of 4 because I'm going to, that equals plus 3x plus 4y equals 8. So that's 12 plus 4y equals 8. Subtract 12 from both sides. Run out of room here. And what I end up with is, for y, 8 minus 12 is negative 4. That's a nice one. And then I divide both sides by 4. And what I find is that y is equal to negative 1. And I started with x equals 4, so I get the point 4, negative 1. So now let's try this. This one's a little bit more complicated than I had anticipated, but 0, 2 is one point. And then the other point is 4, negative 1. Okay, and then now we can see the intersection point right there is going to be negative 4, 5. Negative 4, 5. The other way you could have done this is, because you'll have access to decimals, you could graph this. You could actually just enter both of these into decimals. It would draw the graph for you. You'd see these points, and you'd also see which points to use. Okay. Before we go through all of that, so this is one way of doing it. Looked like a lot of work. Let me show you the way of using decimals. Oops, I don't want that back. I want to clear that out. I need to grab this down a little bit. Let's go to decimals, and I'll show you how to, the graphing calculator. Because you'll have access to this. So we have 5x plus 2y equals negative 10. 5x plus 2y equals negative 10. That's one line. Add another expression, and that one is going to be 3x plus 4y equals 8. 3x plus 4y equals 8. Now notice it does give us x-intercepts, so there's the -2, -2, 0, and 0, -5. We, again, just gave it to us by putting it in there. This one we do get an x-intercept here, 0, -2. We could see that we get this decimal 2.667, 2/3. But I could see also here at 4, looks like -1. I can go here. 4, -1 would be a point I could use. So it gives me that. And then it gives us the intersection, -4, 5. Boom. Just like that. Okay, so you can enter them and use your decimals calculator. And you get the result that way. Or you can do all that work that we just went through. Your choice. Let's check to make sure we got it correct. I'm sure it is. Feel pretty good about it. Yeah, we're good. All right, we'll take a little break. I'll come back and do another set and keep making good progress.